In our last lesson, we looked at 5 steps for graphing quadratic functions. Find which way up it goes, find the y-intercept, find any x-intercepts that there might be, and then have a look at the axis of symmetry, which will be halfway between the x-intercepts if there are any, and then lastly find the vertex. Now, those are all 5 good steps. We saw that on that third step, if you're looking for x-intercepts and you can factorize the function, then that's probably the quickest and easiest way to do it. If it can't be factorized though, you can complete the square and you could actually use that method to find intercepts. But in this lesson, we're using completing the square to do something else entirely. Because rather than just use it to find intercepts, we can also quite cleverly complete the square to rearrange our formula so that it looks like this. Now, this is a special form that I call Vertex Form because it's the form where you can look at this and just read the vertex straight off. Now, y equals, it's still got that a out the front like we've seen before. And if we expand this out, we can see that we'll get a multiplied by x squared. So this is still the coefficient of x squared. But it's rearranged so that it's got other constants in it. It's got x minus h, and it's always minus, plus k, where a, h, and k are constants. Now, I say this is always minus. Obviously, if you're subtracting a negative number, you can get what looks like a plus something in here. But whatever you're subtracting, that's your h. And whatever you're adding here, that's your version of k. Now, h and k are then a little bit special because the vertex, you can just read straight off the chart and say the vertex is hk once you have it in this form. And of course, if you know the x value of the vertex, then obviously the axis of symmetry is the line x equals h. Now, before we look at how to do it, quick little bit of a proof here of how this works. Now, you don't need to write this lower section down here if you don't want to, but just listen so that you're not just taking my word for it. It actually makes some sense. Now, if we look at just this part of the formula, the part where it has something squared, no matter what goes in these brackets, once we square it, that whole section will be positive, right? Now, it's either being multiplied by a, which is a positive number, or a, which is a negative number. And whether a is positive or negative, I've written here if a is positive or if a is negative, that will affect the shape of our parabola. We've already seen that. Now, if we're looking for the vertex, don't forget the vertex on an upright parabola is the lowest point, and the vertex on an upside down parabola is the highest point. So if we look and say, well, this thing is always positive, so if we're multiplying it by a and a is also positive, this will be a positive number. And then we've got to add something else to it to get y. So if we're looking at how small y could possibly be, the smallest it can ever be is when this part is equal to 0, because it will never be negative. So its smallest possible value is 0. Now 0 times this positive number here will just be 0. So we can say that y in that case would equal k. But similarly with our upside down parabola, even if a is negative, if this whole section here has to be positive, and we've reasoned that the top of this parabola is the highest point, then if we're looking for the maximum value of k, and we know that this is a negative number, then if this is a really big number, this will be a really large negative number. So if we want to find the highest possible value of y, to see how sort of tall it is, then we're going to get that highest point when this part here again equals 0, because otherwise we'll have a negative number here, and once we add k, that won't be as tall. So again, it makes sense that we'll get our maximum value of y when this part's 0, and again, that value of y will just be k, whatever that is. So now we've considered both possibilities, and they both turned out the same. We saw that k actually is the y-coordinate of the vertex. Now, what's the x-coordinate of the vertex? Well, if you know the y-coordinate, you can just sub that back into your equation to find the x-coordinate. So let's have a look at what would happen if we did that. If we wrote this all out again, but we said instead of writing y, let's write k, because at that vertex point, y is k, then we're going to have a k on both sides here. So the first logical step is to subtract k from both sides. That'll give us 0 on the left-hand side, and we won't have that plus k anymore. Now if I divide both sides by a, 0 divided by a is still 0, so that's disappeared the a. Now I can take the square root of both sides and say that x minus h must equal 0, and therefore x must equal h. So this is quite a simple little proof here to show we can tell that k is the y-coordinate of the vertex, but we've also proven that when it is, our x-coordinate of the vertex is h. So then there's three things that we need to know how to do today. One is we need to know how to graph a quadratic function when it's in vertex form already. Secondly, we need to know how to put it into vertex form if it's not given to us that way. And then thirdly, we need to look at how we can look at a graph that's given us the vertex and one other clue and use that information to figure out the formula of that parabola. So first step, how do we graph one when it's already in vertex form? Well, we've got those 5 steps and we can do the same 5 steps. We might just do them in slightly different order based on which steps are the easiest. First step, which way up it goes, is still quite easy. It's still this number here, which is our A, that tells us what's happening. And I can see that this is an upright one. Second step was find the y-intercept, and we do that by letting x equal 0. So let's go ahead and let x equal 0. Now you can show your whole line of working, or you can do part of this in your head. I can just imagine this part is 0 and say I'll have -1 squared, so that'll be 1. 1 times 2 is 2, and 2 plus 3 will give me the 5. So I know I've got a y-intercept at 5. So I can go ahead and start graphing as soon as I've got some information. Now normally we'd find the intercepts next, but I'm going to skip straight ahead because I'm in vertex form, so I may as well just go ahead and plot the vertex. Now we've said that when it's in this form where we've got a x minus h squared plus k, the vertex is hk. So here, instead of subtracting h, we've subtracted 1, so h must be 1 and k must be 3. So our vertex is the point 1, 3. So I can go ahead and find 1, 3, let's say it's around about here, label it. And now I've got my vertex, I can draw in my graph. I know that this is my lowest point and it's an upright parabola, so I can draw in something like this, rough sketch, and my sketch is now pretty good. Now can you see the value here of graphing the vertex before I went looking for x-intercepts? Because in this example there aren't any x-intercepts. So that third step, look for x-intercepts, would have made me waste a whole bunch of time. Whereas this one, I'm now pretty well finished. I've got my vertex, I've got all of the intercepts that there are, and there's really nothing left to do. I could draw in the axis of symmetry if I want to, because I can see that that is at the line x equals 1.